Elon Musk's plan to colonize Mars is one of the most ambitious projects of our time. The founder and CEO of SpaceX believes that humanity needs to become a multiplanetary species to ensure its survival. Musk's vision of a self-sustaining human colony on Mars isn't just theoretical. He's outlined a detailed plan to achieve this objective. By developing advanced technology, addressing logistical challenges, and exploring innovative solutions, Musk's roadmap to Mars breaks down into several key steps. The cornerstone of Elon Musk's Mars colonization plan is the development of the Starship, a technologically advanced vehicle designed by SpaceX for deep space missions. Starship is a fully reusable, heavy-lift spacecraft capable of carrying up to 100 passengers or large quantities of cargo. The reusability aspect of Starship is critical for reducing the cost of interplanetary travel and making regular journeys to Mars feasible. Musk believes that for Mars colonization to be economically viable, launch costs must be reduced to as low as possible, something Starship's reusability aims to address. Starship is designed to withstand the intense conditions of both Mars and Earth's atmospheres. It will enter the atmosphere of Mars at a speed of nearly 5 miles per second and will rely on aerodynamic braking, as well as a robust heat shield to slow down and safely land. SpaceX has been rigorously testing Starship's capabilities through high-atmosphere test flights and, more recently, orbital testing. These tests help SpaceX refine the technology and identify any potential issues before carrying humans to Mars. The ambition behind Starship goes beyond just transporting people. It's also built to carry essential infrastructure for a Mars colony. Starship's substantial cargo capacity allows it to carry habitat modules, power generators, food, and scientific equipment. Musk envisions Starship as a transport vehicle that can conduct frequent, reliable trips between Earth and Mars, opening the door to large-scale migration and trade between planets. Before sending humans to Mars, Musk plans to conduct a series of unmanned missions. These initial flights are crucial for testing critical life-sustaining technologies and developing a clear understanding of the surface conditions on the planet. They'll focus on perfecting landing techniques, assessing local resources, and setting up basic infrastructure. For instance, one of the primary goals of these missions is to locate and confirm the availability of water ice on Mars. This resource is essential for producing oxygen and hydrogen, which are needed for both life support and fuel. These unmanned missions will also test systems for harvesting resources and producing fuel directly on Mars, a process known as in situ resource utilization, or ISRU. By experimenting with ISRU technology, SpaceX aims to make future Mars missions self-sufficient. Ideally, ISRU capabilities will allow starships to refuel on Mars, enabling them to make return trips to Earth. Unmanned missions will likely establish preliminary solar power sources and communication systems, creating a basic support framework for future human arrivals. These missions must launch at specific times to utilize optimal Earth-Mars orbital alignments, which occur every 26 months. After the initial successful unmanned test flights, SpaceX plans to launch the first Starship missions with a human crew. The SpaceX colonization program aims to send 1 million people to Mars by using 1,000 Starships sent during the Mars launch windows. These proposed journeys would require 80 to 150 days of transit time, averaging about 115 days. These early human missions will involve constructing habitats and establishing systems for life support, energy, and waste management. Musk's vision includes the creation of Mars habitats that can withstand harsh conditions such as intense radiation and low temperatures. He envisions initial structures built with materials sent from Earth, supplemented by materials sourced from the Martian environment. One of the primary challenges is producing a reliable supply of food. Early missions will likely involve growing food in controlled environments, using hydroponic or aeroponic methods that require minimal soil and water. His long-term plan is to develop sustainable agriculture on Mars, utilizing greenhouses and eventually Martian soil once it is modified to support plant growth. Power generation is another essential component. Musk plans to emphasize the use of solar energy as Mars receives a significant amount of sunlight daily. Solar panels will likely be set up as an initial power source, with potential nuclear power solutions being explored for more consistent energy, especially during the Martian winter. Communication infrastructure is equally critical for a Mars colony. SpaceX's Starlink satellite constellation, originally intended for providing global internet coverage on Earth, could also be adapted to support high-speed communication between the two planets. Elon Musk envisions creating a network of satellites around Mars to facilitate communication with Earth and enhance coordination between Martian bases. For a self-sustaining colony, Musk's plan relies heavily on the ability to utilize Mars' local resources. One of the most vital resources is water, which exists on Mars as ice. SpaceX intends to develop technologies for mining and melting this ice, providing a sustainable source of water for the colony. Water can also be split into hydrogen and oxygen via electrolysis, which would produce both breathable oxygen and hydrogen fuel. To fuel return missions to Earth, SpaceX is exploring the production of methane and liquid oxygen on Mars using the Sabatier process. This process converts carbon dioxide and hydrogen into methane, which can be used as rocket fuel. By establishing fuel production on Mars, SpaceX aims to make round-trip travel to Mars feasible and reduce dependency on Earth-based resources. This step is essential for the economic and logistical viability of Mars missions and could pave the way for interplanetary trade. The financial cost of colonizing Mars is enormous, and Musk has developed several strategies to fund the project. SpaceX generates revenue through satellite launches and its Starlink internet service, both of which have grown into substantial revenue streams. Starlink, in particular, has been marketed to provide high-speed internet in remote and underserved areas, creating a steady income source that could help fund future Mars missions. In addition to these revenue streams, Musk has hinted at public-private partnerships with governments or other private investors to share costs. SpaceX's success in reducing launch costs through reusable rocket technology has also made Mars missions more feasible. By reusing rockets and spacecraft, SpaceX has significantly lowered the cost per launch, bringing the goal of Mars colonization closer to reality. Musk has expressed a willingness to commit his personal wealth toward this vision and has spoken about the importance of financial independence from governments to ensure the mission's continuity. Musk's commitment, combined with SpaceX's revenue streams and cost-effective launch technology, provides a robust financial foundation for the Mars colonization endeavor. Colonizing Mars presents numerous technical and human challenges. The environment is hostile to human life, with low temperatures, high radiation levels, and a thin atmosphere composed mostly of carbon dioxide. Protecting colonists from radiation exposure is a significant concern, with SpaceX developing various shielding techniques, such as using Martian soil or constructing habitats underground to reduce radiation exposure. Psychological challenges are also considerable, as settlers will be isolated from Earth, facing limited social contact and mental strain. SpaceX is researching ways to address these challenges, including designing comfortable habitats and developing support systems that can withstand Martian conditions. Healthcare on Mars is another essential consideration. Musk's vision includes ensuring that colonists have access to medical care, possibly through a mix of telemedicine and advanced autonomous medical technologies. In the long term, Musk envisions the colony as a self-sufficient city with its own industries, schools, and community life. The eventual goal is to create a society capable of surviving independently from Earth. Ultimately, Musk's vision for Mars is rooted in his belief that humanity's future depends on becoming a multiplanetary species. He sees the colonization of Mars as a necessary step to protect civilization from potential global catastrophes such as natural disasters, pandemics, or even existential threats like nuclear war. By establishing a human presence on Mars, Musk hopes to create a backup for humanity, ensuring its survival even if Earth becomes uninhabitable. While numerous obstacles remain, the framework outlined provides a structured approach to one of humanity's greatest challenges. The journey to Mars may be long and fraught with difficulty, but Elon Musk's plan is the closest humanity has come to making this vision a reality. We hope you enjoyed our look into Elon Musk's plans for Mars colonization and invite you back for our next episode of A Godless Universe.